Hello guys, can you hear me now? Let's wait till I can see myself.
Why can't you stay?
Okay, I can see myself now. Can you also hear me? Yeah, I can hear myself. Hey, and guys, I'm back with the microphone. Is my voice better now? With this microphone, can you hear me well? Although the screen, my video is a bit blurry, but it's because I believe that my webcam is damaged, but still you can see me. Sorry for my delay in starting it. The reason was that I was trying to connect my iPad, but it's not working, and I just thought that it's getting late, so it's probably better if I start. Yes, I'm finally back. Yes, I was not. It's not my birthday. I don't know who has said that, but it's not my birthday, guys. Why? Happy birthday. Thank you very much, guys. I'm so happy to be back. What do you guess that has happened for me that I was not available for a month? Yeah, it's not my birthday. I think we should see that who said first. He just... yeah. Yes. Marriage. No, it was not marriage. Where am I from? I always get this question. I'm from Iran. The reason that I was not available was that I was not here in the US. For a month I was in Iran. I was back in Iran. So I was not available for a month. But I was preparing a video for you that I'm gonna upload very soon. In the votes that we had in my Telegram channel, let me share your Telegram channel again in here as well, in case you're not in it yet. In the votes that I had in my Telegram channel, we decided something to talk about, and I am preparing that video about how to reach experts. This is the link to my Telegram channel. How do you still do well at the on-site contest? You are not even participating. Is it like a default branding? I'm not participating in CF contests right now. I'm not participating in on-site contests much anymore as well. Nice. An Iranian message. Yes, I am alive. Yeah, for sure I will answer that. I will answer that at the end of the stream, but probably because you're already waiting so long, probably we should start talking about the problems. Vlog from Iran. If you want, probably I can. I do not have much videos though, but probably I can. Okay, so do you play chess? Sometimes. It's been a long time that I haven't played, but I used to play. Can we follow Yusaku Guide? Yes, Yusaku Guide is very helpful. And if you want, I'm also thinking about making a course as well. Do you think it's a good idea to create a course other than these live streams? Although it's my mind to start fast too, because it's getting too late. No, yes, obviously yes. There are too many courses already. Yes, create the course. Yes. Please provide free also. Yeah, for sure. I will continue having my free content as well, definitely. If you want, I can think about creating a course if you think that it's gonna be helpful. But definitely I will continue having my free content as well. Why were you gone for so long? Yeah, I just told you. I was not in the US. I was in Iran, and internet connection sucks there. Sorry for that. Internet connection is not very good there, and so I couldn't have live streams, unfortunately. I hope that I can, but I couldn't. So shall we start? I know that I'm keeping you waited for so long. Do you think if you're ready, I can start? I switched to this screen because this picture is too blurry and it doesn't feel good. So I changed it. And my iPad is not connected still. Oh, finally it's connected now. Thank God. Okay, so good news. My iPad is connected now. Okay, so shall we start? Begin, yeah, okay. So we start talking about the problems and about the tips, etc. I will talk about that at the end of this stream because I know that you're waiting. Just let me tell you this one sentence. I seriously missed you guys a lot. I mean, in this time that I wasn't doing the streams, I was really feeling bad. And I really missed you guys so much, and I'm so happy that I'm back. I mean, I just got to the US 2 days ago, and instantly I tried to start my streams again. And today I was out, and it was too cold out. You can see that my nose is still a bit red. I don't know if you notice it or not. But I got back soon so that I can start streaming. I missed you guys a lot, honestly. So, okay. Thank you very much. Thank you. Yes, sure. Let me bring the problems and start talking about the problems today. I know that I've already talked for, I think, around 10 minutes. So let's start talking about the problems. Okay, let's start from the first problem. Also, in the meantime, you can just tell me in the chat that how many problems you guys have solved. The first problem that's we should discuss today, the problem A, Fibonacciness. It says that there is an array of 5 integers. Initially, you only know A1, A2, A4, and A5. You may set A3 to any positive integer, negative integer, or 0. The Fibonacciness of the array is the number of integers I such that A of I plus 2 is equal to AI plus AI plus 1. Find the maximum Fibonacciness over all integer values of A3. So you want to set the value of A3 in a way that the Fibonacciness of the array will be maximized. You solve 8 problems? Doesn't it have 7 problems in total? Okay. So, well, in this problem, you have these values A1, A2, A3 is not set. We have to set it, and A3 and A4. Well, we know that Fibonacciness is about 3 consecutive elements, right? It's about 3 consecutive elements. It's either these 3, or these 3, or these 3, right? So the Fibonacciness is about 3 consecutive elements. It's either these 3, or these 3, or these 3. Now, I want to say that for each one of them, what should be the value of, I'm sorry, this is A4 and A5, sorry for that. What should be the value of A3 such that those 3 add 1 to your Fibonacciness? For the first one, if we want it to add to our Fibonacciness, A3 must be equal to A1 plus A2. For this one, if we want it to add 1 to our Fibonacciness, A3 must be equal to A4 minus A2. And for this one, it adds 1 to our Fibonacciness only if A3 is equal to A5 minus A4. So I see that each one of them wants some value from me. A1 plus A2, A4 minus A2, A5 plus minus A4. And I can see that what are these values? And if, for example, 2 of them were the same, for example, if all 3 of them are the same, by setting my A3 to that one, to that value, all these 3 values will add to my Fibonacciness. So my answer is going to be 3. If only 2 of them are the same and one is different, by setting this value to that one, that 2 of them will be okay, two of them will be add to my Fibonacciness. I can reach 2. I can reach the Fibonacciness of 2. And if all of them are different, I can reach the Fibonacci of 1 by just choosing one of them. Let's just take a look at an example to further clarify it. For example, the first case is the values are 1, 1. This is my A3, and then 3 and 5. Well, for the first one, it wants A3 to be 2. Only if A3 is 2, it adds 1 to my Fibonacciness. For the second one, it wants A3 to be A4 minus A2, which is 2. If it is 2, 1 plus 2 is going to be 3, so this 3 adds 1 to my Fibonacciness. And for the last 3, it wants my A3 to be equal to 5 minus 3, which is again 2. So by setting it equal to 2, all of these conditions will be okay, and my Fibonacciness would be 3. So the answer to the first case is 3. For the second one, I have 1, 3, 2, 1. 1, 3, and 2 and 1. For the first 3, if I wanted to add 1 to my Fibonacciness, A3 must be equal to 4. For the next 3 of them, A3 must be 2 minus 3. So it must be minus 1. So it adds 1 to my answer. And then for the next 3, it must be 1 minus 2. So my A3 again must be minus 1. So that my answer would be 1. I see that 2 of them are the same. These minus 1s are the same. And the first one of them is different. So my answer in this one is going to be 2. If I set it to minus 1, 2 of them will be correct. So at the end, I'm going to have 3 values. If all of them are the same, my answer is 3. If 2 of them are the same and 1 is not, my answer is 2. And if all of them are different, my answer is 1. Or in other words, I can say that, for example, in here, I can have a map from int to int. And for example, in here, I just add 1 to CNT of 4. In here, I add 1 to CNT of minus 1. And in here, I add 1 to CNT of minus 1. And at the end, my maximum CNT is going to be the answer. Is it clear for everyone? Or do you guys want to move on to the next problem? I can also show you the code for this one as well. I think I can show you the code very quickly too, because this is a simple problem. Let me show you a code. And it had also a brute force idea as well. Let me show you a brute force idea that I'm seeing a code right now that uses brute force idea. This code. It starts from minus 200 and goes to 200 because my numbers are at most up to 100. It's the best. I mean, we should only set it in the value from minus 200 to 200. Out of this range definitely does not add to my Fibonacciness for sure. So in this solution by Sermenon, he considers all of the possible values that we can set by A3, so it's a brute force, and he just checks that what score does it give to us. This brute force idea works as well. So he just looks at what does it give us. Let me also find a solution that does what I told you. If we take a look at, for example, this code, it's just giving us no, this is not good as well. I think that I'm trying to find one, but even if I didn't find one, the main point was that between checking all those numbers, okay, this is what it gives us. So for example, in this Python code, which is very short as well, he just gets A, B, D, and E, and he will just checks these values, A plus B, D minus B, which is A4 minus A2, and E minus D, which is A5 minus A4. He just checks that how many different numbers do we have in here, and he just prints 4 minus the number of different numbers. So if all of them are the same, the size of this set will be 1. So he will print 4 minus 1, which is 3. If 2 of them are the same and 1 is different, the size of this set will be 2, so he will output 4 minus 2, which is 2. If all of them are different, the size of this set will be 3, so he will output 4 minus 3, which is 1. Is it completely clear? Not clear? It's still not clear? If you are okay with that, put a plus. If you're not, put a minus. Yeah, all these methods work. And yeah, because it is problem A, it has so many methods. You can do brute force, you can do brute force, you can just do the idea that I told you, see that what value, add 1 to the values that works for each 3 of them. Or you could, as you saw in the last Python code, see that what is the size of that set and print 4 minus that number. Okay, so I guess it's clear for everyone. So let's move on to the next problem there. Okay, nice. So let's move on to the second problem, problem B, Farmer John's card game. This problem is saying that Farmer John's n cows are playing a card game. Farmer John has a deck of n by m cards numbered from 0 to n times m minus 1. He distributes m cards to each of his n cows. Farmer John wants the game to be fair, so each cow should only be able to play 1 card per round. He decides to determine a turn order determined by permutation p of length n, such that the pith cow will be the ith cow to place a card on top of a center pile in a round. So there are n cows, and Farmer John has mn cards. He wants to give m cards to he has gave m cards to each of the cows, and he wants to choose a permutation so that in each round of the game the cows play with in this turns that you see in this permutation. The first time the cow number P1 plays, then the cow number P2, then at the end the cow number Pn. And he wants it to be in a way that all the numbers will be in increasing order. The numbers on the cards will be in increasing order. You have to find out such a permutation that works here, or say that no permutation can work. So you want to find a permutation so that if the cows having these cards with these numbers, they can play in each round using this permutation in the order of this permutation, so that each card is greater than the previous card, and each cow can choose any of the cards from their deck. Okay, so I hope that the statement is clear to you. I just say it very quickly as well, because I assume that you already know what the statement is as well. If anyone had any issues with the statement, let me know. So what we can say in this problem is that you have n cows and each of them have some numbers, and we know that each number from 0 to n minus 1 has been seen exactly once. It has appeared exactly once in these permutations. So assume that we have 2 cows, cow number A and cow number B. Assume that cow number B comes after cow number A. Okay, assume that cow number B comes after cow number A. Then I must be able to find the matching between the cards of cow number A and cow number B, such that in each pair in this matching, the cards that cow number B has a greater value than the card that cow number A has. So what I'm saying is that if cow number B comes after cow number A, I must be able to find the matching between the cards of this cow number B and cow number A. I must be able to find the matching between them such that the card of cow number B has greater value. For example, let me tell you this with an example. For example, if you take a look at the first test, you have 2, 3, 0, 4, 2, and 1, 5, 3. For example, in here, we just see that cow number 2 comes after cow number 1. So I must be able to find the matching between the cards of these 2 cows such that the card that cow number 2 has a greater value than the card that player 1 has, cow number 1 has. For example, we can just have this simple matching. Match everything with the one below it. We see that in each pair, the card that cow number 2 has a greater value. So they can play those cards in the same turn. So that's the point. I say that if cow number B comes after cow number I, there must exist such a matching between them. Okay, is it clear for you guys? So is it clear so far? There must be a matching between them. If it is clear, please put a plus or use this 100 emoji. And then I move forward. Then we will see that how we can check if such a matching exists or not. Okay, nice. Now, how do you think we can check if such a matching exists? How do you think we can check if such a matching exists? After sorting, you combine them all and check if still sorted. Practice. Sort and compare. Sort everything. Sort them. Sorting. Yes, exactly. If you want to check for two cows, it's just enough to sort all of the cards that they have in increasing order. And if cow number B comes after cow number A, that matching exists if and only if you sort the cards of both players, the first card of the first cow has a greater value than the second card of the first card of the second cow. In other words, we sort them and match them one by one according to their position. And in each pair, the card that player B has, cow number B has, must have a greater value. So if we sort the cards of both of them, the cards that the second cow has must have greater values. Okay, that's how we can check if cow number B can come after cow number A. Now we can do this for every two cows. For every two cows, first we can sort all the cards that they have and then check if one of them can come after the other one. One of them should have greater value in all of the positions compared to the other one. So one of them must have greater values in all of the solutions, all of the positions compared to the other one. Then we can say that this cow comes after the other cow. If it is not possible, if for example at some position the first cow has a greater value and in some positions the second cow has, it's impossible to somehow arrange them. Do not forget that we are doing it after sorting them. Do not forget that we are doing this after sorting the cards. Okay. And then we can say that if that happened, if for each two cows this was possible to do this, then the answer is yes, it is possible to find such a permutation, and it's enough to see for each cow how many cows should come before that cow. For each cow, just count the number of cows such that they have smaller values in all the positions. For example, whenever you solve such a situation, you just add CNT of this one by one. It means that this cow has one additional cow that comes before it. At the end, it's just enough to see that for each cow, how many cows come before that. For example, if for this cow at the end its score is 5, it means that 5 cows come before this. So it must end up in the 6th position. You can easily find the position of each cow afterwards by just counting that how many cows should come before this cow. So basically the whole thing is this. We start from the beginning and sort the cards of all the cows, and then we will consider each two cows. We consider each two cows, and if we see that for these two cows, in all of the positions, this cow has a smaller value than this one, or vice versa, it has greater values than the other one, we will add one to the CNT of the cow with greater values. Otherwise, if it didn't happen, if in some positions the first one had greater values, in some positions the second one had, we say that it's impossible to find an answer, to just sort them in any way. If that happened, we add one to the CNT of the cow with the greater values, and we should just see that this way we can easily find out the position of each cow at the end. So this way we can find the permutation. Is it clear? If it is clear for you, just put a plus or use this emoji again. All cards of a cow should give same remainder divided by n. Yes, that is right too. That is right too. We can also say that all cards of a cow should no. Wait a second. No, not same remainder. It's possible that I just assume that in each round all the values must be in increasing order. But if in all the rounds they must be in increasing order, if in all the rounds combined they must be in increasing order, then what we say is true as well. Yes, if the deck will not reset after each round, that is right. Also, they must have the same remainder by n. I will show you the code as well, also to check that if it will be reset or not. I will also show you the code as well. Let me bring the code. Let me find a good code. Okay, yes, and I just checked the code, and yeah, so other than this one, other than what I'm considering, you know, the main point was that we also have this condition. I mean, I initially assumed that in each round we start from the beginning and each card must be greater than the previous card. But in all the rounds, they will just add cards on the same pile. So the first card of this turn must have a greater value than the last card of the previous turn. This should always happen as well. So based on this, when we know that this should happen, we can just say that consider the cow that has the smallest value. It should go first because it has 0. Because it has 0, it should go first, definitely. So it will go first and all the other cows will put their cards. And then again in the nth turn, in the turn number n, this cow should go again. So what should be the value of its next card? What should be the value of its next cards? Because this one has the card number 0. So it should go first. And then all the other n-1 cows will play their turn. And then we will go back to this cow. And this cow should again put another card. So what should be the index of that card? Because that is the turn number n. So what should be the index of that card? Exactly, greater than all of the first n cows. But at the same time, we know that we have 1 from each value. So it should be exactly n. Because at the end, in the pause, our numbers must be 0, 1, 2, 3, 4, and so on. To n m-1. So, I mean, if you look at the cows, they must be like this. First, we have 0 here, then 1 here, then it goes to n-1 here, and then it starts again from n plus 1, and then goes to 2n-1, then again 2n plus 1, and then goes to 3n-1, and so on. So, other than what we said, we also have that all the cards that a cow has must have the same remainders modulo n. So that's also something that must happen. All the cows that we have, for each cow, all the cards that this cow has must have the same remainder by n. So if that happens, the answer is yes, otherwise the answer is no. Is it clear? If it is clear, please again use the plus emoji or just put a plus or use this 100 emoji. I will show you code as well, just in a moment. I just want to see that if you completely understood the solution. So the main point is that the first cow first goes. I mean, because we have 1 from each of the numbers from 0 to n-1, the cards at the end should look like this: 0, 1, 2, 3, 4, 5, 2, and n-1. At the end, they must be like this. So the point is that the first cow goes, it must put 0. Then the second cow puts 1. Then the next cow puts 2 and to n-1. Then the second card that the first cow will place must be n, and so on. So you will see that the cards that they will place, it will be exactly by this pattern: 0, 1, 2 to n-1, then n plus 1 to 2n-1, then 2n to 3n-1. So in each cow should have all the cards having the same remainder modulo n. Now let me also show you this code. If you take a look at this code, it has all the cards. It first gets all the cards and he will store that who has some particular card. He just stores it in a map. He could also define an array, but he just stored it in a map. And then he just has a 4 from 0 to n times n, and he will just see that if the person who has card number I must be the same as the person who has the card number I modulo n. They must be equal. If they are not equal, is okay, is false. And then if is okay was false, he will see at -1 and he will continue. Otherwise, he has a 4 from 0 to n -1 and he will print who has that card. For example, the one who has card number 0 should go first. Then the one who has card number 1 should go second. Then the one who has card number 2 should go third, and so on. So he will just see that who has each card. He will make sure that the person who has card number I is the same as the person who has the card I modulo n. And then if it was not okay, he will see out -1. Otherwise, he will just see out who has card number I from 0 to n -1. Is the code clear as well? Yes, finally there is a stream again. And from now on we start our streams again, and soon we will have our topic stream too. So, and there are other good news as well. Probably I will also start a course as well. I will let you know if I make sure of that. Yeah, so show one more code. Okay, so let me find the Python code. Let's see the first solution. The first solution is always the smallest one. So let's see how has he solved it. Okay, he just defined an array of size n by m, and then he has a 4, and he will get all the cards that each person has. This is a very complicated code. I think it takes time to understand how exactly he has done it. Let's look at a simpler code. This is also another Python code. As a second code, I'm showing you a Python code so that if you probably want to see Python code as well. The previous one was C++. This one, it says that it will get all the inputs as a string and he will split them. He's getting each line as a string, I guess, and then splitting them. And then he will just append that x is owned by person number I. Value x is owned by person number I, and then he will sort all of them. And b is equal to I of 1 for I in A from 0 to n. So it is the indices of the people. And if I of 1 for I in A is equal to b times m, yeah, so basically he will just check that if these indices that he has as the second index. This is also an advanced code an advanced code in Python. He will just see that who owns card number 0, who owns card number 1, who owns card number 2, and who owns card number n-1. He stores that in array B. You know, he says that for I in A colon n, it means that the first n elements of A. And he then multiplied this array by m. So he puts this array next to itself m times, and he will see that if this gives the same array as A, if it gives you the same array as m, he will just print all the values in array B. Otherwise, he will print -1. So he says that who owns card number 0, who owns card number 1, and so on to n-1, and he believes that the next n cards must be again the same period, the same values. The next one again the same values. That's why he will multiply this array by m and checks that if it gives the same array A or not. And if it does, he will just output that. Otherwise, he will print -1. This is an advanced Python code, and it's very short, as you see. Is it clear as well or not? If you had any issues on that, let me know. Otherwise, let me know to move on to the next problem. You went to hibernation or what? No, I was not in the US in the last month. That's why I couldn't. I have joined Telegram channel. Great. Yeah, we will have our votes in our Telegram channel. Yeah, I will start topic streams again soon. Yeah. My code, this simpler. If you want, you can take a look at that. Guys, also if you prefer to move on to the next problem, let me know to move on to the next problem. But anyway, the code that you suggested is this similar. He has got all the cards and he is just considering, I mean, I guess you are just considering the same thing. You will just consider that if they are the same periods repeating each time, you are just printing those values, otherwise you print -1. I think it's basically the same thing. I didn't go into details, but it looks the same. Okay, so let's move on to the next problem. Sure. Let's move on to problem C. Game of Mathletes. So it says that Alice and Bob are playing a game. There are n integers written on a blackboard represented by x1, x2 to xn. There is also a given integer k and an integer skull that is initially 0. The game lasts for n half turns in which the following events happen sequentially. Alice selects an integer from the blackboard and erases it. Let's call Alice's chosen integer a. Bob selects an integer from the blackboard and erases it. Let's call Bob's chosen integer b. If a plus b is equal to k, add 1 to the score. Alice is playing to minimize the score while Bob is playing to maximize the score. Assuming both players use optimal strategies, what is the score after the game ends? Well, in here, I want to show you that Alice can do nothing. Alice cannot do anything to make the score any smaller, and Bob can do whatever he wants. Bob can reach the maximum possible score. See, n is even here, right? N, the value of n is even here. I'm saying that Bob can consider the best possible way to match these cards. Bob, in his mind, can consider the best possible way to match the values. Bob can consider, okay, I want to match these cards like this. I want to match these two, and so on. Bob, in his mind, can choose that how he wants to match the numbers, and he can for sure do this. Alice cannot do anything. Why? Because any move that Alice does, Bob can just choose its pair. Again, next time if Alice chooses this one, Bob can choose its pair. Again, next time if Alice chooses this one, Bob can choose its pair. And so on. Each time that Alice chooses some of them, Bob chooses its pair. So Bob, in his mind, will match these items, will pair these cards in the way that he wants. And then, however Alice plays, it doesn't matter at all for Bob. He just sees that in his ideal pairing, what is the pair of that element, and he will just use that. Right? So that's the whole thing. The point is that Alice cannot do anything. Whatever Bob wants happens. Okay. If n is odd, then it would be different. Yes. But because if it is even, if it was odd, because Bob had to put one aside and Alice could choose that one aside, Alice could ruin Bob's strategy. But now, since n is even, no value is aside, all the cards are in a pair. So each time that Alice chooses a card, Bob can choose its counterpart, its pair. Do you guys agree with this? Is it clear? If it is clear, again, put a plus or use this emoji if it is clear so far. So what I'm saying so far is that whenever Alice chooses a card, Bob chooses his counterpart. And so basically Alice doesn't do anything. What Alice doesn't matter at all. Alice doesn't do anything. So it's just enough to see that if Bob wants to just match these cards, make them into pairs, what would be the maximum number of matches, maximum number of pairs such that their sum is equal to k? Okay. Simply finding the number of pairs with some k. Exactly. Problem is now simplified into the number of pairs with some k. Yeah. I don't know what you mean exactly, but simple two-pointer. Yeah. We can just say that as well. So basically we want to make maximum pairs such that their sum is k, and the rest of the pairs can be any way, in any way that they want. So we want to make maximum number of pairs that we want. And it's easy as well. We can just see that how many of each number do we have. We know that our k and n are limited. Our k is at most up to 4 times 10 to the 5th. And all the xi's are also up to n. So I can just keep CNT of I. CNT of I means that how many i's do I have. And then I have a 4. I just see that how many i's do I have. How many k minus i's do I have. If they were different, I will add minimum of these two values to my answer. If they were the same, if I was equal to k half, I will add CNT of k half divided by 2 to my answer. So this is for I not equal to k half, or in other words, I is not equal to k minus I will add this value. For k half, I will add CNT of k half divided by 2 to my answer. And this way, the answer that I will get at the end, the value that I will get at the end is the maximum number of pairs that we can create. And Bob can just do it as he wants. For example, in the first case, you can see that our first test case is this 4, 4, 1, 2, 3, 2. So we see that CNT of 1 is 1, CNT of 2 is 2, CNT of 3 is 1. At the beginning, Bob in his mind can match this 1 with this 3 and this 2 with this 2. Whenever Alice chooses one card, Alice chooses its pair. Whenever Alice chooses a card, Bob chooses its pair. So this way he will make sure that he will get 2. And in order to find out what is the maximum number of pairs with some k that we can achieve, first of all, we see that how many 1s and 3s do we have. We see that we have 1 from each one of them. I can add minimum of this 2 to my answer. So 1 will be added to my answer. Then 2 is k half, is 4 divided by 2. So each 2 of them can create one good pair as well. So CNT of 2 divided by 2 will add to my answer as well. So this way my answer is going to be 1 plus 2 half, which is 1, 2. So the answer is going to be 2. So this is how we can get the final answer. Is it clear too? If again this one is clear as well, put a plus or use this emoji. Okay, so two-pointer was possible as well. It's not a map though. The solution that I told you, it has an array. I mean, because it's up to 4 times 10 to the 5th, it just has an array, and it's gonna be so simple. You could also use two-pointer. You could just sort all the elements. You could just sort all the elements and start from the beginning. And as long as the sum of this one, I mean, you can see these two values. If the sum of them was equal to k, you will add 1 to your answer and move both of the pointers. The first one forward, the second one backward. If it was greater than that, if it was greater than k, you will move the greater one backward, because this one cannot be matched with anything anymore such that it can get answer k. So you move the right one back to the left. If their sum was less than k, you move the left one rightward, because this one cannot be matched with anything, because it's right now matched with the greatest remaining item and it does not give us k, so it's not useful anymore. So you will go forward. So you can also have this two-pointer approach. Each time if the sum was k, you will add 1 to your score and move both of them. If it was less than that, you will move the left one. If it was greater than that, you will move the right one. This way you could get the answer as well. Both map and 2-pointer, both of them are possible on this problem. Let me also show you a code for this problem, problem C. Let's see which code is a good one. Yeah, for example, we can take a look at this one, this code. It just gets, for each query, gets n and k, and he has a map, he defines a map. A map, when it's defined, is empty by default, when it is defined. So this map is empty right now. And ans is equal to 0, he has several x's, he's seeing x, and he will update everything at the same time. When he gets an x, if right now we have any k minus x's, we subtract the number of them by 1 and we add 1 to ans. We just match this x with that k minus x. Otherwise, if it was not possible to match, he will just add 1 to the map of x, mp of x. And at the end, he will just see out the answer. So this way would work as well. Okay. Are you guys completely okay with this? Shall we move on to the next problem now? Problem D. Or not? If you have any questions about it, let me know. Otherwise, we'll move on to problem D. Simpler frequency area code. If you want, we can take a look at that as... Thank you very much for sharing it. If you want, we can take a look at that. If you want, we can move to D. But anyway, if we couldn't look at it right now, you could also share it in our Telegram channel. And everyone can watch it. If you guys want to discuss the contest or anything else, you can join our Telegram channel. There are so many people there and we have an active community there. We can talk more there. You can join there. And also, if I have wanted to have a poll there, votes, I will put the votes inside the channel. For example, what you want the topic streams to be about, or anything else that I want to ask you, what videos you want me to create, etc. So you can join there to talk about those things. And guys, how many of you are new to our live streams? For how many of you this is the first live stream that you have? Yes, I'm active there. I'm active in our Telegram channel. We have a Telegram channel and also a Telegram group. I will put the link of the group there as well, where you can just see the group as well and discuss things with the other guys. We have a channel and we have a group. I think we can discuss all the problems today. So it's the first time that you guys watch. Yeah, I guess so. I guess that there might be so many people that they are watching for the first time. And who are the people who have watched so many live streams from this channel? And can you just say that approximately how many live streams have you watched? Who believes that he has watched the most, or probably he's one of the people who has watched most of the live streams or topic streams? 20 plus 20. Nice. Yeah, I remember you. Anonymous. 30 at least. Nice. Watched everything from September. Wow. Nice. It's so nice. Awesome. Yeah, I thought that probably today we're gonna have some new people as well, because it's been a month since the last time. So probably things have changed. New people have came. Am I frozen? No, I'm not frozen. Okay, so let's move on to the next problem. So, problem D. Subtract mean sorts. We are now reaching the problems that I just read them quickly. So I hope that still for D I have a solution. And I think for E and probably even for F, I don't remember yet. I think for them have solutions, but we have to talk about it and see. Let me know if you think anything is not right. For this one, the thing that came to my mind, first let me tell you the statement. It says that you are given a sequence A consisting of n positive integers. You can perform the following operation any number of times. Select an index I and subtract minimum of AI and AI plus 1 from both AI and AI plus 1. So you will subtract the minimum of these two consecutive values from both of them. Determine if it is possible to make the sequence non-decreasing by using the operation any number of times. Well, basically, when you consider two consecutive elements, AI and AI plus 1, and you will subtract minimum of AI and AI plus 1 from them, at least one of them becomes 0, right? At least one of these two values becomes 0 when you do this. Either this one becomes 0 or this one becomes 0. If the second one becomes 0, anyway the first one becomes 0 later on as well, because at the end we want it to be non-decreasing. If we can do all the operations such that we will be successful at the end, anyway AI should turn into 0 at the end. Either in this turn or if in this turn it's not 0, for example this is 3, this is 0, later on you should make it 0 because it should be in non-decreasing order. So if you do an operation between AI and AI plus 1, AI must definitely become 0 at the end. So if you consider all of your operations, consider your rightmost operation that you had. This is the right, among all your operations that you've done, this is the rightmost one. Then definitely this one must turn into 0 at the end, and everything before that must be 0 too. So this is how your array will look at the end. And you know that all the elements after this are remained unchanged because you haven't done any operation on them. This was the rightmost operation that you've done. Anything after that is not changed. So you should somehow be able to make a prefix 0, and then one element is unknown, its value we don't know that for now, but the values after that will remain unchanged. This is how it will be, right? So what we can say is that at the end it will look like this. If you consider two elements and you will subtract minimum of them, one of them will become 0, so everything before that should become 0 as well. So basically I start from the beginning. First of all, I say that if A1 is greater than A2, the answer is no. It's not possible. Because if A1 is greater than A2, there's no way to make A2 greater than A1 in the future. Because if we want to subtract A1, we have to subtract the same value from A2 as well. And there's no other way to subtract any value from A1. So A1 will always remain greater than A2. So in this case, the answer is no. Otherwise, assume that A1 is less than or equal to A2. So what I say is this: if A1 is less than or equal to A2, why not subtracting, why not doing an operation on them? Why not decreasing A1 from both of A1 and A2? Why not making this one 0 and subtract A1 from A2? Okay, so the main thing that I'm saying is that if A1 and A2, if both of them, if A1 is less than or equal to A2, we can do an operation on them. The only reason that we might not want to do this is if we want to keep A2 big such that we do an operation between A2 and A3 and we can subtract A3 more. So see what's happening. I'm saying that the only reason behind not wanting to do this operation is if we want to do an operation between A2 and A3, and for that we want to keep A2 large, such that when we do an operation between A2 and A3, A3 will be decreased by greater amount, so such that it will be less than 3, less than A4. But even if that happens, we know that anyway A2 must become 0. So anyway, this operation should happen between A1 and A2 as well afterwards. Because if this happens, if we do an operation between A2 and A3 first, if we first want to do an operation between A2 and A3, we know that for sure A2 must turn into 0 and A1 must turn into 0 as well. So anyway, we have to do this operation afterwards. And still A1 must be less than or equal to A2. So later on, both of them will be decreased by A1. Right? So anyway, later on, they will be subtracted by A1. So I'm saying that what I'm saying is that I can do that at first and just go forward. I can start from the beginning and go forward like this and do this operation between each two consecutive ones. And I can see that if at the end the sequence that I want can be made or not. I mean, at the end, my sequence will be in increasing order or not. If at any time I see two consecutive elements, such that these two elements are the second one, the one that comes after, is greater than the previous one, less than the previous one, the answer is no. Otherwise, I can make them in increasing order. So my answer is gonna be yes. Does it make sense or not? If it makes sense, put a plus or use the 100 emoji. You have to keep on decrementing so that we are giving ourselves best chance of having next elements are larger than current elements. Yeah, basically that's the idea. So, okay, nice. I will show you your submissions as well. Nice, nice. Let me see the submission. Awesome. Awesome. So this is the code that you suggested by Anonymous. So it's saying that he gets the values, and while he just does the same greedy approach that I was saying. While a.size was greater than 1, he will just compare a0 and a1. If a0 was greater than a1, as I said, the answer is definitely no. He will break. Else, if a0 was less than a1, he just subtracts a0 from a1 and he just destroys a0 afterwards. Otherwise, he destroys both of the first two elements. And he will go forward. If at the end, if it was possible, if in no points if this never happened, that a0 is greater than a1, the answer does not become 0. I mean, okay will not be 0, and he will see out yes at the end this way. So this way, my answer, I can get the answer I want. Is it clear? Okay. Guys, did you understand this part of the proof completely? Because this was important. I mean, these parts that I mentioned to you is important. It could cause problems. I mean, the point that I said, yes, it's true that if I make a1 smaller, it's gonna be better for my future. I have more chance that it is less than the next element. But maybe I do not want to make a2 smaller. First, I want to do an operation between a2 and a3. First, I want to do that so that I can decrease a3 more and then decrease a1 from a2. So this was a small point that you should take care of. Do you understand the issue? This is something that you should make sure that this is very important part of the proof. So the point is that you always want to do this operation between the first two elements in the first time, and you don't want to keep a2 greater, so that you first do an operation between a2 and a3 and then do an operation between a1 and a2. Why? The reason is that if a1 is 0, it doesn't matter. So you can first do an operation between a1 and a2, it's meaningless, and then destroy a1. So we can assume that a1 is greater than 0. If a1 is greater than 0, in case it's better for you to do operation on a2 and a3 first, We just prove by contradiction. Assume that we want to do an operation between A2 and A3 first. We definitely know that in this operation, A2 must be greater than A3. Right? Because after this operation, it must remain greater than 0. And it must remain greater than even A1. It must be greater than or equal to A1. So from the beginning, A2 was at least A1 plus A3. So we could first do the operation between A1 and A2, and still it would be at least A3. So it would make A3 0 anyway. So it never happens that A2, we want to keep A2 greater and first decrease it by A3, decrease A3 by that, and then do A1 and A2. This was an important part of the proof. Make sure that you think enough about this part. This is important. This could cause problems if we couldn't say this. Okay, anyway. So if you're okay, we can move on to the next problem, problem E. Okay, so let's move on to the, if you understood it well, let's move on to problem E. Let me bring it. Problem E, graph composition. It says that you are given two simple undirected graphs, F and G, with n vertices. F has m1 edges, while G has m2 edges. You may perform one of the following two types of operations any number of times. Select two integers u and v such that there is an edge between u and v in F, then remove that edge from F. Or select two integers u and v such that there is no edge between u and v in F, then add an edge between u and v in F. Determine the minimum number of operations required such that for all integers u and v, there is a path from u to v in F if and only if there is a path from u to v in G. So basically, we want to keep adding and removing edges in F such that the connected components of F will be the same as the connected components of G. First off, let's talk about all the edges that must be deleted. First, let's talk about all the edges which must be deleted. Okay. Consider that in graph F, you have an edge between two vertices like u and v. In F, you have an edge between vertices u and v such that in G they are in different connected components. For example, in G, u is in this connected components and v is in this connected component, but in F they have an edge to each other. In F, this edge must be deleted for sure, right? In F, you should definitely delete this edge because otherwise u and v will remain in the same connected components, but we know that in G they are in different connected components. But we said that we want the connected components of F and G to be the same. We want that two vertices have a path to each other if and only if they have a path in G. So if in G they are in different connected components, so they do not have a path. In F, it's not possible to have an edge between them. So first of all, we should delete all such edges. We should delete all such edges between U and V that we know that U and V are in different connected components in G, right? So that's the first thing that we can say. We delete all such edges. After deleting all such edges, we are sure that all connected components of F have some vertices that because all the edges that we have are between vertices that are in the same connected component in the graph G, we are sure that all the connected components of F only contain the vertices that also are in a connected component in G. So we are sure that, for example, let's enumerate all the connected components in G. Let's consider that we enumerate all the connected components that we have in G. For example, this is component number 1, connected component number 1. This is connected component number 2. This is connected component number 3, 4, and 5. We have several connected components. We are sure that in F, all of the vertices belong to the same connected component. For example, all of the vertices in this connected component belong to 1. I mean, in G, they are all in component number 1. all the vertices in these connected components are in connected component number 4 in G. Again, all the vertices in this connected component are in connected component number 1 in G. These ones are 2 in G. These ones are also 2 in G. These ones are 5. These ones are 4. So we are sure that all of them are in the same connected component in G. All of the vertices in the same connected component in F. We just need to also add edges between these connected components such that we merge all of them with all of the ones with the same value as well. So basically, afterwards, we just need to see that how many connected components we will have and subtract the number of connected components that we have in G from that. For example, when in G we have 5 connected components, but in F we're gonna have 4, 6, 8 connected components. We need to have 8 minus 5 equal to 3 merges, so that we have 5 connected components in here as well. So we need these 3 merges. So first of all, we just delete the edges that are between 2 vertices which are in different components in F. Then we are sure that all of the connected components of F are, all of its vertices are in the same connected components in G as well. But we might need to add some edges. It's just enough to see that how many connected components we have in F and how many connected components we have in G. And we subtract these values and we get the number of edges that we have to add. Yes, we first delete and then we add. And this way we can just get the answer that we want. Is it clear? Again, if it is clear, please put a plus or use this emoji. I hadn't read the word path in the question and thought that we need to make edges equal. Oh yeah, if it was like that, it would be simpler. It was just the number. We could just XOR these 2 graphs and just see that how many edges that XOR has. Yeah. Oh, isomorphism. That would be very harder. Yes, I will show a code as well. Is it clear for the rest of you as well? Shall we move on to a code? It's better if we write it in our Telegram channel. Probably others can help as well. In the live stream, probably we cannot talk about debugging the solutions. If you want, we can also talk about that, but I guess that you might not want to discuss that in the live streams. Okay, so I will show you the code that Anonymous has sent. Let me bring it. So I'm showing the codes that you guys sent. This is a code by Anonymous. This is a hard code though. He just uses DSU, and what he does, this is not a good code to show, I guess. But anyway, he just gets all the edges, and he will just see that first of all, if the connected components of 2 vertices were not the same in G, he has to remove that edge, so he adds 1 to answer. Otherwise, he add that edge in DSU of F, and at the end he will just see that if there was in the graph G 2 vertices are not in the same connected components in F, he had to add 1 edge to those 2 vertices in F such that they will be in the same connected component. So basically he's using DSU. He will see that you could, instead of DSU, use DFS as well. In order to find the connected components, you could either use DSU or DFS. Both works. You do not necessarily need to do DSU because you do not need it to be online. You could do a pre-process and see all the connected components and then see that if you have an edge between 2 vertices that are not in the same connected component in G, first you add 1 to your answer and remove those edges. After that, in the remaining edges, you will do DFS and see that how many connected components do you have. And you subtract the number of connected components in G and add that to your answer. This way you could get the final answer as well. So yeah, I can also show you another code. Jiangli or tourist. I don't think Jiangli and tourist participated in this contest. Did they participate in the contest today? But anyway, I'll show you another code too. I mean, other than this code, I will show another code too. Let me find a good code. So as I said, you could also do a DFS instead of DSU. DSU works, DFS works as well. So, but anyway, let's take a look at this code. I guess it's by another Chinese guy. So he just also gets all the edges as well. He uses DSU2. He will first guess all of the edges and he just merges them. And then he has a 4 on up to M1. So in the graph G, for any edge that he gets, he will merge them in DSU. And then he will have a 4 again on the vertices in F. And he says that if, as I said, and as we saw in the previous code, in the previous solution, if two vertices were not in the same connected component in G, but they had an edge, he adds 1 to the answer, otherwise he merges these two vertices in graph F. So this FA is for graph G, it's the father in graph G. This F is the father in graph F. These are not good names that he has used, but anyway, they're different names and it works. But these are not good names. So this FA is for DSU in graph G, this F is for DSU in graph F. So you will see, he will merge these two otherwise. If this edge must not exist, he adds 1 to AND such that he will make sure that this edge must be deleted. Otherwise, he just sets this one as the parent of the other one in graph F. So he merge these two. At the end, he has a 4 from 1 to n, and he will just add to answer if f of I was equal to I, but in f of I was not equal to I. In other words, at the end, he will see that which connected components, some vertex is the root of it, but in G, that vertex is not the root of its connected component. So it means that it must be connected to some other component. It needs an additional edge to get connected to another component so that all of them will be combined. So you will count the number of them and adds to the answer. So this way you could get the answer as well. Is it clear? Oh, Jiangli might get to 4,000 tomorrow. So Jiangli might become a tourist. It's interesting. I didn't follow their ratings recently. Oh my god, Jiangli is first again. Tourists lost the first place. And Jiangli is close to become a tourist. Nice. It would be funny if Jiangli becomes a tourist. And while tourist is not a tourist. What if we make a vector of nodes for both the graphs, sort that and check for similar ones and update them? Well, you need to make sure that first you delete the edges and then you add the edges. That's what you need to make sure of, because after deleting the edges, the shape of your connected components will change, and probably at the beginning two vertices were in the same connected component and you didn't need to add an edge between them. For example, you can see this in the first example. You see that in here 1 and 3 were in the same connected component from the beginning, but after you delete the edges between 1 and 2 and 2 and 3, 1 and 3 are not anymore in the same connected component, so you have to add an edge at the end for them. So the answer is 3. Even though 1 and 3 were in the same connected component from the beginning, but after you delete the edges they are not anymore, so you need to add an edge between them anyway at the end. Okay. Though I'm not sure if Jiangli gets to 4,000, he will become a tourist or he will become a Jiangli. Maybe he will become a Jiangli in Codeforces. I don't know, that's a question that I want to find its answer. Jiangli didn't participate in this contest, Yes, this contest is not definitely rated for him. Div 3 is not, but I think he said tomorrow. Tomorrow is a Codeforces contest. Div 1 plus Div 2. And then there is another contest in 3 days. Okay, what is the rating of this question? It will be out very soon, but I guess probably like, what do you guys guess? I think if I want to guess the rating of this problem, I would say like probably 1700. Probably 1700, I don't know. 1400 to 1500, 1100, I don't think so. 1600, yeah, maybe. Yeah, I think 1600 makes sense as well, yeah. Okay, so now let's move on to the next problem F. I'm not sure if I thought about problem F. Okay, F is this one. I've read this problem though. I think we have to solve it together in here. I had ideas though about this problem. Problem F, multiplicative arrays. It's saying that you're given integers k and n. For each integer x from 1 to k, count the number of integer arrays A such that all of the following are satisfied. Size of A is from 1 to n, each AI is from 1 to k, and A1 times A2 times A of A is equal to x. The product of all elements is x. Note that two arrays B and C are different, either if their lengths are different or there exists an index such that they are different in that index. So anyway, you have to count the number of arrays with length from 1 to n, each element from 1 to k, and the product to be equal to x. Well, basically what you have to do, it's a combinatorial problem. I think I know the solution now. I think now that I thought, I think I know what should we do. You should have some knowledge about combinatorics in order to solve this problem. Well, the main thing that you have to say, let me share the screen. Will you make a contest discussion tomorrow? Probably. Yeah, probably. I will let you know today in Telegram if we have a contest discussion. But yeah, with high probability we have that. Well, there's a problem named stars and bars. I'm not sure if you have heard about it or not. This is a very famous combinatorial problem. It just gives you the answers to this equation, x1 plus x2 to xk equal to n. The number of answers to this equation, where each one of them are at least 0. Are you familiar with the stars and bars? I think we have talked about it before. We talked about these stars and bars before in our topic streams, haven't we? Yeah. So if you have watched the topic streams before, you have seen this idea. I really recommend to you to watch the topic streams. That's super important for you guys if you want to grow. I will send you the link of the topic streams here. It's super important for you to just be familiar with things that if you want to learn new things, especially dynamic programming, I recommend you to watch the dynamic programming topic streams. It's gonna be super important. But anyway, I will go through that very quickly, and then you can watch more information in the topic stream. Do you remember in which topic stream I discussed this? Let me see if I can find it. Do any of you guys remember in which topic streams I had it? Number, sorry, but which one of them? Sir, can you tell a website for Learn C++? There are some websites, many websites to learn C++. I guess even Yusaku Guide covers that as well. I know that Yusaku Guide covers algorithms, what syntax of C++. I'm not sure, but probably it does as well. But there are also so many resources. If you just search about C++, you can see so many of them as well. Yes, CP algorithms is a good source as well. if any one of you can find out in which topic stream I talked about this stars and bars approach and tell me this in the chats, I would appreciate that a lot. I will start explaining it to not waste your time more. But anyway, if any one of you found that out, please let me know, such that I will send it in here. But the main point is that if you want to count the number of answers to this equation. Oh my god, we lost the tab. Okay, we have it again. So first of all, assume that for each xi, we have the condition that xi's are at least 1. First, let's solve it for this case. Each xi must be at least 1, and they are all integers. They all must be positive integers. In this case, the answer to this would be, we can assume that it's like we have n balls or n stars. Let's say we have n stars. We could either use stars or we can use balls. But anyway, let's assume that we have stars and we want to use k-1 bars in between of them to split these stars, such that we split them into k groups. We want them to be in k groups, right? We have k values. So x1 at the end would be the number of stars before the first bar. x2 would be the number of stars between the first and the second bar. x3 will be the number of stars between the second and third bar, and so on. So the answer would be the number of ways to place these bars in the middle of these stars. The number of ways is gonna be, there are n-1 spaces, and from them we have to choose k-1 of them. So it would be n-1 choose k-1. Our answer would be n-1 choose k-1, right? Actually, we would be a more appropriate word. What do you mean? In which topic stream did you discuss combinatorics? I think it was in number theory, in one of the number theory, definitely in one of the number theory ones. I can take a look at it and let you know. I will also tell you in Telegram channel about it. But right now, because we are in the middle of our topic stream, our live stream, probably it's better if I don't look at it right now. I was replying to someone else. Okay. So the answer, the number of ways would be n-1 choose k-1. Now, if all the xi's are at least 0, and we want to solve it for the condition that all the xi's are at least 0, I can, in my mind, add 1 to each one of the numbers. And then we know that if I add 1 to each of the numbers, its answer will be added by k. But now all the numbers are at least 1. So the only difference is that I'm adding k to the sum. So the number of ways would be n plus k-1 choose k-1. So it's just like I've added k to my sum. That's all. So this way I can get the answer. I will become IGM in 10 years. Nice. So anyway, this is how I can solve this equation. And I believe that this is very important in this problem, because when you have two values, k and n, you want to find n numbers such that the product is equal to k. K is up to 10 to the 5th, and n is up to 9 times 10 to the 8th. I think that, first of all, you should find the prime factorization of k is p1 to the power of alpha 1, p2 to the power of alpha 2, and so on to pl to the power of alpha l. And then assume that we want to use, like t numbers, we want to use t numbers, we want to have t numbers like a1, a2 to at, such that their product is equal to k, to x, to some x. Let's say that, let's rename this to x as well. We want it to be x. Well, the point is that if we know the prime factorization of x, we can say that for each of these prime numbers, for example, for p1, we have alpha 1 p1. I can see that how many p1s each of these numbers have. if this one has x1 p1s, if this one has x2 p1s, and this one has xt p1s, the sum of these values must be equal to alpha 1. So the point is that it's like we have so many of these equations, and my answer is going to be, for example, for this one, the answer to this equation, because each one of them are at least 0, the answer to this is going to be alpha 1 plus t minus 1, choose t minus 1. And so on for all the other numbers. So it's going to be the product of these combinations. Okay. So it's going to be the product of these combinations at the end. And then I can just consider that when I have this, I can just also see that in how many ways all of these numbers are greater than 1. I believe that this is going to be very helpful if I do that. If I want to make sure that none of them are non-important. What do I mean by non-important? I say that AI is non-important if it is equal to 1. If a number is equal to 1, it's not important. We can also delete it. So I'm thinking about deleting all the ones, and then if I wanted to add ones, then I will add. So first I will assume that I cannot use any ones, and then considering that I cannot use any ones, I will add ones later on if I wanted. This is the idea that comes to my mind right now. Let me take a look at some codes as well to make sure that other ones have used the same idea, or take a look at the solution, because it seems like the tutorial is up right now as well. They have uploaded the tutorial as well. So let me also share my screen. So if I could continue, if I was continuing this idea, we could say something else, but let's first take a look at these ideas. This tutorial first. It says that, for this solution of problem F, it says that first, when n is large, how many of the array elements will be 1? Many of the array elements will be 1. Yes. The number of non-1 elements cannot be too large. Yes. The number of non-1 elements will be the sum of, at most, the sum of these alpha i's. The number of elements which are not 1 will be at most the sum of these alpha i's. And we know that this sum is at most log of k. Because each of them are at least 2. Each of these pi's are at least 2. And for each of these alpha i's, we are multiplying our number by something that which is at least 2. So the number of values which are not 1 is at most log. So, considering this, if I want to continue that, what I'm saying in here, because I have at most log of k different numbers, if I delete all the ones, if I assume that I do not have any ones, for any value from 1 to log of k, we can see that how many ways do I have by this solution. But I know that so far it's possible that some of them are 1. I want to delete all the cases that some of them are 1. How can I do that? I can just have some ans of, for example, t. Ans of t right now is the number of answers to these equations. So some of them can be 1 as well. But if I do not want any of them to be 1, I can just have a 4 on all the previous answers, assuming that I have fixed them so far. I'm sure that they do not have ones anymore. And for each one of them, I can consider that, for example, if I have ans of I here, I can subtract from ans of t, ans of I times t choose I. Because it is the case where I choose I of them, and I say that in these I points, we have non-values which are not 1, and in the rest, we have ones. So this say, if I subtract this, I will have all the answers that my values, the values that I choose are not 1. And then for any of these cases, from ans of from 1 to ans of t, I know that the number, what is the number of ways if I use the numbers which are not 1. And then I can add ones in the middle of them. For example, if I have consider some ans of I. So I have I values which are greater than 1. Consider that these I values are somewhere. I can add several ones to each of these spaces. And I know that the sum of these ones that I can add to these places has some upper bounds. I know that there are also some ones that I'm not using, some ones which are going to be outside and I'm not going to use them. If I consider the ones that I'm not using them as well, the sum is going to be exactly equal to n minus I. N minus the number of values greater than 1. And this is again an equation that I can solve using the method that I told you. And then I can solve the problem this way. So the problem will be done. I will take a look at the rest of the editorial as well. But so far, did you understand what I was telling you? Did you understand the solution that I told you or not? If you understood it, put a plus or use the 100 emoji. If you didn't, put a minus. Anyway, I will also tell you the solution in the tutorial. We will read that as well. But did you also understand the solution that I told you? If anything is not clear, also let me know. If it is not clear, let me know. May you refer again to how the DP may be used? Can you repeat shortly? Yes, basically, thank you for the emojis. Yes, basically, what I'm saying is that, first of all, I know that the number of elements that their product is equal to k. If I consider that each of them are greater than 1, the number of elements that I can have is at most log of k, because each of them are greater than 1 and their product is equal to k. So I will have at most log of k elements which are greater than 1, right? So the point is that I can see that how many ways do I have to have exactly I numbers which are greater than 1. I told you that using combinatorics I can find the answer to it. And when I find the answer to it, it's just easy to afterwards add ones in the middle of them, in the spaces in between of them. And I can count that in how many ways. If I have I numbers greater than 1, I can place these I numbers and then put ones in the space between them. And I can see that how many ways do I have to add ones in between them, and I can multiply that by ans of I and get my final answer this way. If I want to take a look at the tutorial as well, and let's see that's how do they solve it. What they do is that try to pre-compute all arrays without one and then use combinatorics. Okay, this is the same thing that I told you. They try to pre-compute all the arrays that does not have one, and probably they add ones in middle of them later on. It says that the naive solution is to define fk of n as the number of arrays containing n elements with the product of k. We could then try to compute this by considering the last element of the array among the divisors of k, giving us, okay, they consider the last element. What is the last element? Fk of a, n is gonna be for each j that j is divisible by k, k is divisible by j, it's gonna be fj of n minus 1. We use n minus 1 elements to create j. And fk of 1 is equal to 1. The answer would then be sigma of I from 1 to n f1 of I. Sigma of I from 1 to n f2 of I to sigma of I from 1 to n fk of I. However, this leads to an O of n k log of k solution which exists are time constraints. We need to optimize this approach. Okay, so basically in here it says that we will use at most 16 non-1 elements because it is at most log of k and log of k is less than 17. So it must be less than 17 as well. So based on this observation, it defines a dynamic programming approach. dp of I and j represents the number of arrays with product I containing only j non-1 elements. The recurrence relation becomes dp of I and j equal to sigma of p divisible by I, p greater than 1, dp of p and j minus 1. Base case is that dp of I and 1 is equal to 1 for I greater than 1. So it just makes sure that each number is greater than 1. I think it should be I divided by p, not p, because it says that p is greater than 1. So I guess that P, he's putting P in this place and the rest in the previous one. So he should put I divided by P here. I only believe that this part should be replaced by I divided by P. And this computation has the time complexity of O of K log 2 of K as we perform this additions for each I. Yeah, because we just have a 4 on all the divisors of numbers, it would be O of K log K additions. And to calculate fk of n, we enumerate the numbers of non-1 elements from 1 to 16. For j non-1 elements in the array, we have n minus j elements that are 1. We need to choose j positions for non-1 elements. Fill these positions with dp of k and j possible sequences. Exactly. So we will fix that in which positions we have 1, and then we fill these positions with dp of k and j position. In which positions we have 1, in which positions we have non-1s, we fill the positions with non-1s with dp of k and j. This gives us this dp fk of n is going to be sigma of j from 1 to 16, n choose j dp of k and j. Therefore our answer, which is sigma of I from 1 to n fk of n, is going to be sigma of I from 1 to n, sigma of j from 1 to 16, I choose j dp of k and j, which is equal to j from 1 to 16 dp of k and j times sigma of I from 1 to n, I choose j. And this value is equal to n plus 1 choose j plus 1. This sigma is equal to n plus 1 choose j plus 1 times dp of k and j. So at the end we will get this answer. So we can, this way, each answer can be calculated in O of log squared of k, given an overall time complexity of k log squared of k. I also tried to read the tutorial for you as well, so that if you were not comfortable with the previous solution that I thought, you will consider this one as well. So basically the problem is using star and bars. Basically what it's doing is similar. It's using some dp of I and j is the number of ways to make I such that we have exactly j non-1 elements, j non-1 elements, and this can easily be updated because you can have a 4 on all the divisors of I, and the sum of the divisors from 1 to n is O of n log n. In total the order is going to be good. I mean the sum of the number of divisors of numbers is going to be O of k log k. So it's going to be good. And this dp can be calculated easily then. And when you calculate this dp, you can just see that how many ones you want to insert in between of them. That can be easily calculated too. The number of ways to insert ones in the middle. If you want to have j non-1 elements among all the n numbers you have, first you choose that in which j elements you want elements to be not 1, and then fill that those positions in dp of k and j ways. And then you can simplify this sum by putting this sigma inside the brackets, and we know that sigma of I from 1 to n, I choose j, is equal to n plus 1 choose j plus 1. This is a simple combinatorial thing. If you want, I can also talk to you about the proof of these parts. This is, I mean, it is easy to show that this is equal to this. It's like among n plus 1 elements, we are choosing j plus 1 numbers. Why? It is sort of like in here, in this sigma, we are like assuming that what is the j plus 1, the person number j plus, the element j plus 1, number j plus 1 that we are choosing. If we choose that whenever it is, we have to choose j other elements from the previous I elements. So it's going to be the sigma of I from 1 to n, I choose j. So basically you can simplify this, and at the end you will get this value. So this is how you can get it as well. I hope that it was clear. I know that it was still a bit complex. I hope that it helped you to understand the solution. Did you understand or not? Do you want me to explain any part? What's the correlation between how did you ensure that you are taking values only greater than 1? In this solution, in this dp, he will just make sure that he will have a 4 on all the p's which are greater than 1. And guys, it's super cold here right now. I think my thermostat is not working, and it's just super cold here right now. And I'm wearing a t-shirt. It's a very weird situation. He has in his for, he will check that P is greater than 1. So this way, he will make sure that all the elements are greater than 1. In my solution, I did not ensure that all the elements are greater than 1. I assume that they can be 1, and then I decrease the previous values. I assume that they can be 1 too, and then I decreased all the bad bits. I said that for each I will decrease from ans of t, ans of I times t choose I. This way I can update my answer. So they both can work. Is the problem what number of non-decreasing arrays of length n where all elements are within some certain range? Non-decreasing arrays of length n where all elements are within some. I'm not sure about that. Why? The number of ways we spread all the instances of that one factor throughout the indices. But basically, we do not need it to be in increasing order. We just want some of them to be equal to something. Suggest me after Python which coding I have to do. If you mean which language, I suggest C++ to you if you want to do competitive programming. The rating of this problem, I think it must be 2000 or something. Okay, yeah, try to solve it. It would be great. Nice. Nice. I haven't read problem G yet. Do you guys want the solution to problem G as well or not? If you want that, we can do this as well. Do you guys want the solution for problem G as well or not? Okay, so I will talk about that as well. So problem G. I have to read it from the tutorial though. We will read it together from the tutorial. So it says that today Alice has given Bob arrays for him to sort in increasing order. Again, at this point, no one really knows how many times she has done this. Bob is given two sequences A and B, both of length n, all integers in the range from 1 to 2 and appear exactly 1 in either A or B. In other words, the concatenate sequence A plus B is a permutation of 2n. So each array has n numbers, and each number from 1 to 2n has appeared exactly once in the arrays. Bob must sort both sequences in increasing order at the same time using Alice's swap function. Okay, so Bob must sort both sequences in increasing order at the same time. Alice's swap function is implemented as follows. Given two indices I and j, it swaps ai and bj and swaps bi and aj. At the same time, it swaps ai and bj and aj and bi. Given sequences A and B, please determine if both sequences can be sorted in increasing order simultaneously after using Alice's swap function any number of times. We just want to see if we can sort them by using Alice's function. We have to read the editorial because I haven't thought about this problem before. Non-decreasing meaning, for example, the first two factor in the I take a look at it later. So let's talk about this problem first because I started this one. Sorry. This one, it says that let's go over the hints first. Consider AI BI as the ith pair. Can two elements ever become unpaired? Consider AI as okay. Yeah, it says that if AI and BI are some pairs, they are always pairs with each other. They are always together. So if you have AI and BI, whenever you're doing an operation, they are still pairs. Only they change their relative positions. I mean, the first one goes to array B and the second one goes to array A. They change their arrays, but they are still paired with each other. So that's the first hint. Every operation keeps the pairs intact. The best way to think about the operation is like this. Swap the pairs at indices I and index j, and index I and index j, and flip each pair. So basically it's equal to this, yes. So we can see that each pair always remains a pair. That's an important thing. The operation allows us to swap two pairs, but it also results in both of them getting flipped. Is there any ways to swap two pairs without flipping anything? Yeah, I think if we use another element, if we first swap this with another element, and then swap that element with this element, and then swap this element with that. Instead of swapping A and B, first swap A with some C, then C with B, then again A with C. By doing this, I think nothing will be flipped. Yeah, so if you want to swap I and J, instead you can pick some index K, where K is not equal to I and J. And then first you do operation on I and K, then on J and K, finally on I and K again. This is the exact same thing that I was telling you. This way, the order of pairs will remain intact as well. The pairs will not get flips. Is it clear so far? Are you following me so far? And thank you guys very much for your emojis. It really means a lot. Let me also use the same thing. I really missed these streams to have with you. So happy to see you again. Thank you. You cannot thank you also for using random emojis as well. So is it clear so far? If it is clear for you, just put a plus or the 100 emoji. If it is clear so far. I'm kind of still shaking and I see that my nose is still red because even my place is too cold right now. Okay, so let's continue. If you have any questions, ask me. So as far as I see some 100 emojis and no one is asking questions. So let's continue. So we can also keep the order of the pairs. Can you flip two pairs without swapping them? Can you swap two pairs without swapping them? I think that must be possible as well. But how? Let's see how. Just perform operation on pairs I and J and then follow the procedure from, okay, yeah. Yes. And you are effectively swapping, then swapping and flipping. Therefore, the final result is the flip of two pairs. Yes. So you can also flip two pairs without swapping them as well. You can first swap and flip them, and then do the procedure 2, which only swaps them without flipping. So first you swap and flip, and then you swap. So it's like those two swaps cancel each other and you're just flipping them. So this way it's like we have done the operation swap and the operation flip independent of each other. That's very interesting. So we do not need to swap and flip. We can just independently swap two elements, two pairs, or we can independently flip two pairs. We do not do them at the same time. This is interesting. Can you flip one pair on its own? Can we flip one pair on its own? We should be able to do that. But how? If we... Let's take a look at it. I think we should play with this. It says that no, it is not possible due to... Okay, yeah. It's not possible. This is not possible due to the parity invariance. The operation involves performing two swaps at the same time, which means that it is impossible to end up in a situation where the number of swaps is odd. Yes, that's right. It's not possible to flip one pair on its own because you see that each time you're flipping two pairs. So the number of pairs that are swapped is always even. So you cannot do it on one element. It always remains even. You cannot change them. This is an invariance thing. It's parity invariance. So now if you see the solution, in the final solutions, the pairs must be sorted in an increasing order of minimum of AI and BI. We prove this by contradiction. Suppose there exists a pair AI and BI where AI is less than BI and AI is smaller than minimum of the previous pair. In this case, it becomes impossible to place this pair after the previous one. Yes, definitely. As AI would always be smaller than the preceding element, regardless of orientation. Yes, so it says that we can sort them first by the minimum of them, and then since all AIs and BIs are distinct, there's exactly one valid final ordering of the pairs. Awesome. It's been very interesting so far, since swapping any two items in an array in an array an arbitrary number of times allows for sorting. By definition, we can sort the pairs in this order. Thus, the solution is to initially sort the pairs based on minimum of ai and bi. Okay, yes, we can sort them. It's just enough to sort the pairs in this order, and then we have to just change the order of each pair. And the problem simplifies to determine whether flipping pairs allows sorting. We can solve this using dynamic programming defined as follows: dp of 1 and I is equal to 1 if it's possible to sort up and including pair I using an even number of flips where pair I of 1 is not flipped. Yeah, there are basically 4 cases. Either you have used even number of flips or odd number of flips, and the last one is either flipped or it's not flipped. So there are 4 cases, and you can first define the base cases, and each time you can just update these 4 cases from the previous ones. At the end, you should only consider the cases where you have used even number of flips at the end, and they are equal to 1. At the end, if dp of 1 and n is true, or dp of 2 and n is true, the answer is yes, otherwise the answer is no. So this is how problem G can be solved. I literally read it from the tutorial. I hope that it's clear for you. Do you recommend the MIT Introduction to Algorithms Spring of 2020? To be honest, I do not recommend watching university content much, because they are not optimized for competitive programming very much. University stuff is for just some just learning the name of the algorithms and some small intuition about everything. So you learn so many things, but you have a small intuition about all of them, and you cannot solve problems in any of them. But in competitive programming, you have to have a deep understanding of each topic. So for example, you first learn only one topic and you go deep on that, and then you move on to the next topics. So basically, if you want to study university in a short amount of time, you will learn a lot of algorithms, but you don't know them very well. You know them you cannot even solve problems with them. But in competitive programming, it's different. If you have the same time in competitive programming, you might want to focus on some specific topics, but go deeper on them. That's why I do not recommend watching university courses that much. Yes, it's basically introduction, yes. I really recommend to you, as I said, I really recommend to you to watch the topic streams. I'm just making exactly for the same situation that you're describing for you if you want to learn competitive programs. I really recommend to you watching, starting from this dynamic programming, it has 20k views right now. 20k people have watched it, and I've got a lot of good comments about it as well. So I really believe that it's helpful for you guys. I also added some of the books in case you want them, but I do not really recommend books that much as well. I just added them because probably you guys want them. But anyway, I recommend to you to watch this topic streams. I believe that they can help you a lot to learn this stuff. Awesome. No, just 1-2 sections completely, and first view from the rest. Yes, the first chapter of Arthur Engel, one of my favorite. Yeah, I have not seen that book, but interesting. What order do you recommend studying beginner topics for competitive programming? I probably need to make a video about that as well. In the video that I told you about what to do and what not to do to get out of newbie, I told you that when you are in the newbie states, what you have to do and what you do not have to do. And I told you that what topics to learn. I told you to focus on brute force, implementation, and math topics at the beginning. I again recommend to you to watch those videos as well. Let me share them to you. These are the things that you should do. These are the things that you should not do if you want to get out of newbie. I really recommend to you to watch them. And I'm editing the video for how to become an expert. After that, I can make a video on how to become a candidate master as well. Yeah. I'm literally shaking right now for the weather here. So, did you guys understand it well? I'm gonna start topic streams very soon as well. So, we're gonna add more videos, more topic streams, and you're gonna learn more things. I'm gonna put votes in the channel to see that what you wanna see. Damn, there's weather, bro. Yeah, I can do that, but I should leave here and wear sweater then. Let me see if I'm... Yeah. So, probably I'm gonna do that Div 2 contest tomorrow as well. CM video fast, yeah, sure. Given an array of n integers, count the number of sequences whose product is divisible by k. Interesting. It puts that in the Telegram group. I will put the link of the Telegram group in the Telegram channel as well, where you can discuss these things. I will talk about those stuff very soon. And we're gonna start our topic streams as well. Probably I will dedicate one of the topic streams to talking about the stuffs and general guideline things. Okay. So it was so nice to have our topic streams again. So happy to see you again and having a topic streams. I'm gonna definitely see you soon, probably tomorrow in the next contest, Div 2 contest that we have. Thank you guys for joining. See you next time. Bye bye.